Today, we will show you the main features of the Resilience Dashboard, a tool developed as part of the InCube project. The Resilience Dashboard is built to track on-site safety, environmental impact, and waste management for construction sites. Here are some ways you might use it on-site. For example, if a worker walks into a restricted area, a wearable device alerts both them and their supervisor and logs the incident on file. If noise levels get too high, you get a warning before hearing damage happens. You'll also get alerts for things like extreme temperatures or other environmental factors that are a stress to worker health. Additionally, the tool tracks where each type of waste from your site goes for full visibility into the life cycle analysis of the building materials. The dashboard pulls together everything: worker safety, site conditions, and waste management into one simple place. Now, let's move to the product demo. Let's start with the real-time monitoring model. The tool monitors different site parameters such as temperature and humidity. You can see the values in these graphs. These are static because there are no sensors on site yet. Once the sensors are installed, you'll see real-time values. You'll also find different types of environmental precautions. For example, if the temperature is in the range of 15, no precaution is needed. But if it moves into this red range, you'll see a different message. The system sends these messages so stakeholders know what's happening on site and how to respond. Next, there's acoustic monitoring. LC Peak captures sudden loud spikes that can cause hearing damage, and LEX 8H measures daily noise exposure levels. One of the precautions is that if you have a LEX 8H level of 88.3, you'll get a notification saying the exposure is very high and you should take a break. If the peak level is low, no precaution is needed. If you scroll down, you can also see this as a graph once the sensors are installed. In the historical model, you'll see a peak here, a graph showing what temperature or humidity was recorded over time. You also have acoustic monitoring here. That covers real-time monitoring. You'll also want to review the data later. That's what historical monitoring is for. Inside the dashboard, you can see different tabs: temperature and humidity, acoustics, alarms, events, and BIM integrated parameters. For temperature and humidity, you pick a date range. Here you can see the peaks. For example, on March 23rd, there was a temperature peak. If you keep a safety log, you can check whether there was a risk or incident on those days and see if temperature played a role. You can also export the data as a CSV file for later analysis. Now for the acoustic data. This shows the acoustic levels recorded while the sensors were on site. For this demo, the acoustic values come from Trento, and the sensors were installed last year. So in 2025, you can see both the high and low levels. From there, you can export this data to a CSV file and check the alerts. Having sensors on site is useful, but knowing what's happening matters too. The system can send alerts if the temperature goes too high or too low, so you can react quickly. Here you can see all the data collected from the Trento demo. You can analyze it later and export it as a CSV file if needed. Next, you have the events. These show when the safety sensors were active on site. Take a look at the table description. It tells you the type of event at that moment. Keep alive means the worker was walking. Standby means the worker was standing still for a long time. Standby end means they started moving again. Missing DPI means the worker wasn't wearing the required personal protective equipment. So each event has a meaning you can analyze later. You can see many of these events, along with the time, the location, and the tag number. No name is shown, just the tag, for privacy. You can also see the battery level and the coordinates, so you know exactly where the worker was at that time. Now, let's take a look at the Waste Management Dashboard and how to calculate the final KPIs. For quantitative parameters, you need the weight of the waste and the number of containers used, the design surface, and the available space on site. These parameters help quantify the waste. For technical parameters, you need to know the construction year, the type of work, and how the element connects to the disposal center, whether the waste is dry, mixed, hard, or soft. You also need to know if the component is a partial material that can be recycled. For environmental parameters, here's how you calculate them. You need to know the level of transformation required for recycling or reduction. For example, whether it's contaminated, mixed, aggregated, or needs dismantling. You also need to know the emissions produced during transport. These come from the cost calculator. If there's any concrete-based waste, wood, steel, or generic waste, like plastic, paper, insulation, or glass, include that too. Also note the country, since environmental parameters vary by location. You'll also need the cost of transportation, both within the site and for further locations. Now let's go to the map view. For example, here's the Trento demo. The tool analyzes what kind of waste was generated on site and shows nearby waste and recycling centers, both close and far options. You'll also see the costs, which we saw on the table view, for the nearest and farthest recycling centers. If you click on the recycling center icon and then click on the name hyperlink, you'll see the website of that waste or recycling center. This gives you a more organized way to track where your waste is going. It's useful during the design or pre-design phase, so you know in advance where everything will end up. If you scroll down, the final output is the KPI. This was done for the Trento demo, and the parameters and results were strong. This is the mix management range, meaning the site management is satisfactory, but could be further optimized. The quantitative KPI was in the yellow range, reflecting its mid-level management score. This one was closer to high values, and the final shared KPI was 0.5, landing it in the mixed management category. The final KPI takes all these parameters and shows whether the recycling and waste management at the Trento demo site was good or not. The final KPI showed it fell within the range of good practices for the Trento demo. That concludes the demo of the Resilience Dashboard, a tool designed to integrate on-site safety and waste management for construction sites. Be sure to follow us on YouTube, LinkedIn, and check out the InCube website for more information.